All right, it's extension time with extension 10.5 on simulations. Now, I want to make note of one thing in this video. In this video, I'm going to talk about things such as a random number generator. You're not going to know how to actually do that by watching this video. We are going to do that in class tomorrow. However, what I do want you to understand is once we get the numbers from the random generator, how to understand and interpret it. So don't worry about actually figuring out where I got these numbers from, but worry more about actually interpreting what I'm doing. So we have a vocab word right here, and it says that a simulation is an experiment that is designed to reproduce the conditions of a situation or process. Simulations allow you to study situations that are impractical to create in real life. So things that, like, for example, we're talking about the number of students in Illinois that wear glasses. Well, there's no way that you can actually calculate that because it's not possible. It's impractical to actually do that. All right, so example 1. You don't need to write any of this down. I do want you to write the work. But you don't need to write these problems down if you don't want to. So here's what it says. A couple plans on having 3 children. The gender of each child is equally likely. Design a simulation involving 20 trials that you can use to model the genders of the children. Use your simulation to find the experimental probability that all 3 children are boys. So the first thing we have to do is come up with some type of simulation. Well, here's what we have to start with. In this simulation, we just need to have things that either represent two things. Now, in this case, it's either a boy or a girl. So we can use a coin. A coin represents a 50-50 shot, which is the same thing is true in having a boy or a girl. So if you flipped a coin 20 times, and let's say that you have heads as boys and tails as girls. And these are the results you got right there. So we chose an experiment that has 2 equally likely outcomes, as I said. Let H be represented by a boy and tails T represented by a girl. So if we look at this, we want to know the probability that all 3 children are boys. So we look up here and we notice that we have 1, 2 chances that we're going to end up with the probability of having 3 boys. So 2 out of 20 gives us 1/10. Now this is called the trial. Since we did a trial run, a simulation, we have 20 total trials and HHH occurred 2 times. Therefore, the experimental probability is 1/10, 0.1, or 10%. All right, here's the next one. Now, this is not going to make any sense to you how I'm getting this table, but we will go over that tomorrow in class. There is a 60% chance of rain on Monday and a 20% chance of rain on Tuesday. Design and use a simulation involving 50 randomly generated numbers to find the experimental probability that it will rain on both days. So what we're going to do is we're going to use a random number generator on a graphing calculator, which I will show you how to do tomorrow. We're going to randomly generate 50 numbers from 0 to 99. Now, the reason why we're only going from 0 to 99 is because the probability rain on both days. So each day represents a digit in the double-digit number. If we had 3 digits, that would be for 3 days. So that's why we go to 99. So this generator, this is what it gets right here, this table. This table are all of the results, which I'll show you how to get tomorrow. So since 60% of chance rain on Monday and 20% chance rain on Tuesday, this is the part that's going to take a while to look at. Since it's 60%, look at what we did here. The first number represents Monday in each of these digits. The second number represents Tuesday. So if we look at the number 52, this is Monday, this is Tuesday. Since a 60% chance of it will rain on Monday, We take the numbers 0 through 9. There are 10 numbers. 60% would represent 6 numbers out of 10. So because 6 numbers, we're just going to say that 1 through 6 represent it will rain on the first day. So if we look here, is 5 1 through 6? Yes, 1, 2, 3, 4, 5, and 6. So this means it rained on Monday. Now, the second day, it's 20%. So we're going to actually represent 1 and 2 to represent 2 out of 10, or 20%. So this number right here is 1 or 2. So that means it rained on both days. So 5 and 2, it rained on both days. So as we go through, we circled all of the numbers that this is true based on our random number generator. You'll notice that there are 7 numbers that it rained both days out of 50 total trials. So our probability is 7/50. Example number 3. Now we're going to use a spreadsheet to do the random generator. And I'll show you tomorrow on Google Spreadsheets how you do that. Each school year, there is a 50% chance that the weather causes 1 or more days of school to be canceled. Design and use a simulation involving 50 randomly generated numbers to find the experimental probability that weather will cause school to be canceled in at least 3 of the next 4 days. So here's what we have to do. We're going to actually use a random number table in a spreadsheet. Here's the spreadsheet right here. Now, in this spreadsheet, we just have random 4 numbers. These represent 4 days. The first number represents the first day, the second number represents the second day, and so on. We have a 50% chance that the weather causes 1 or more days of school. So since it's a 50% chance, we're going to do this. We're going to let digits 1 through 5, since that's 50%, 1, 2, 3, 4, 5, that's 5 numbers out of 10, represent school years with a cancellation. The numbers in the spreadsheet that contain at least 3 digits from 1 through 5 represent 4 school years in which at least 3 of the years of cancellation. So all we do is this. We want to know at least 3 out of 4. So if at least 3 of the numbers are from 1 to 5, then it's canceled. So if you look here, 7, 5, we only have 2 numbers in the first one. In B1, we only have, 1, we only have 2 in this one. We only have 2 in this one. We only have 1 in this one, the 5. 4 is not between 1 and 5, is between 1 and 5. 6 is not between 1 and 5. 2 is between 1 and 5, and 9 is not. So here there's only 2 that are between 1 and 5, or from 1 to 5. This is the first one in which 3 of the numbers, 3 of these numbers are from 1 to 5. 2, 2, and 5. So since this represents 3 or more, we highlight it. So as you go through, this is a suggestion, that as you go through and check them, highlight all of the ones that work. And then at the end, all you do is you write what your answer would be. And that's this. There are 17 numbers that contain at least 3 digits from 1 to 5. 50 trials, therefore the experimental probability is 17/50, or approximately 34%. Now, your study tip is this. To create a 4-digit random number table in a spreadsheet, highlight the group of cells to use for your table. You're going to format the cells to display a 4-digit whole number, and then you're going to enter this formula in each cell to actually run this random generator. I will go over this with you. To show you how this all works.